Hello everyone. Today we are going to explain static routing. Static routing can build our routing table. Our routing table can be formed in three ways: direct, static, and dynamic routing. HCIE. Today we are discussing static routing. HCIE. If in the future we configure a static route, it will appear in our routing table with a protocol labeled as static. Static routes are often manually configured by network engineers. It's simple, but we also say that during this process, it has certain drawbacks. The drawback is that it cannot adapt to changes in our network topology and requires manual intervention. For example, during this process, if we say, in the future, let it find 20.0.0.1, who should it find? It should find 10.0.0.2 to forward to RTB. If during this process there is another router here, this router is our RTE4. During this process, we can also use 4 to find this RTC. But in this case, if we instruct it to first find this RTB, what if there is an issue with RTB? Then I would let it find RTC, which means I have configured two static routes here. However, if there is a problem with the link between RTC and RTB, it cannot detect this remote failure, and I would have to manually perform a switch. So in this process, it has its advantages and disadvantages, making it more suitable for simple, stable, and small networks. In this process, if we configure just one route, RTA needs to forward packets with the destination address of 20.1.1.024. Then, in the routing table of our RTA, what do we have? There is only one directly connected route, which is 10.0.0.0. Now, this does not match with 20.1.1024. Therefore, we need to manually configure a static route so that our RTA can successfully forward data to 20.1.1.0. Now, in this process, we need to see how to configure it. First, its format here is called, and in this context, this is its format, and you need to write the destination and the destination mask afterward. Also, our next hop. For example, in this process, when we configure it in the future, it will be the IP address. For example, now we have an IP address. My own IP address is 10.0.0.1 with a 24-bit mask. In this context, for instance, we have another device corresponding to it, like between this device and that device. We connect them, and here is another device. We connect these devices together, specifying their IP addresses, and as we say, the device names like 123. Now, in this context, we say this interface address here is 10.0.0.1, and this IP address over here is 10.0.0.2. Now, in this process, between 2 and 3, let's say their addresses are 23.0.0.2 and 23.0.0.3. If in this situation, we need to configure the IP addresses after configuring them here, one cannot directly reach 3 because this is not a directly connected route on it. It doesn't know that to reach 23.0.0.3, it just needs to find router 2. So here, we need to manually configure it, which is equivalent to someone coming and telling it. If in the future you want to go to 2, 3, a little bit, 3, then you can find 2, 2. So how do you configure it? Here, we need to input IP route static, which is its format. And now hereafter, I need to follow up with the IP. The IP value is ours. The destination network segment you want to go to in the future, which is 2, 3, a little bit, 0, also needs to be configured with a wildcard. Here, for the wildcard, we can write 205.255.255.0 and then follow it with our next hop. That is to say, if I want to find it, I will definitely go through R, the next hop, which in this process is the interface of the router connected to me, its IP value. Now in this process, we can use this address, 10.1.1.2, which is its next hop. Who am I looking for? I go through R to find R3. Besides this method, we can also use IP route static here. In this process, we have our next hop. It can be written as 10.1.1.2. Besides the next hop here, we have the first two as 23.0.0.0, and here we can choose not to write its subnet mask, but rather the mask length. For example, we write 24, followed by the next hop, 10.1.1.2. Now, in this process, this is our first method of writing, which means we follow it with the next hop. Besides following it with the next hop, in this process, we can also change the next hop to the outgoing interface. For example, if my interface here is G001, then when I write a static route in the future, I can write it like this. IP, like static, the format in front is the same, and then I need to ensure the destination is 23.1.1.024. Here we can write 24, or 255.255.255.0. For example, here we write 24, and then follow it with our outgoing interface. In this process, we need to write J001. Now, during this process, we can choose between these two methods. Of course, we can also have both our outgoing interface and our next hop here. For instance, in this process, we have IP route static. Now, during this process, we can write it like this. 23.1.1.024. First write our outgoing interface J001, and then write our next hop, 10.1.12. Any of these three methods can be used to configure our static route. In this context, it's simply that, first, we specify its next hop. Second, we specify its outgoing interface. And third, we specify both the outgoing interface and the next hop. When creating our static route, we can choose, but specifically for our point-to-point, P2P. That is to say, point-to-point links, point-to-point interfaces. For example, if we encounter a theory interface, the default protocol it uses is the P2P protocol. So here we need to specify the outgoing interface. However, if it's for our broadcast interfaces like the ones we commonly see, these are all our broadcast interfaces, such as when we use cables or fiber optics. The protocol they run is the Ethernet protocol, and at this point we must specify our next hop. If during this process we look at some examples, now in this process we need to configure between our RTC and RTA. Static routing allows us to facilitate direct communication between 10.0.0.0 to 14 and 20.1.1.0 to 14. As for data packets, they are forwarded hop by hop. Therefore, all devices from my network to the destination need to have a route to the destination IP. The data flow is bidirectional, so if I can send data out, the other side must also be able to send it back to me. In this process, the data packet we initially send out will have the source IP written on it. The source IP is the address of my outgoing interface, which is 10.0.0.1. Now, who am I trying to reach? The destination IP I am aiming for is 21.1.0.0, that network segment. Now, in this process, let's say we have DIP here. The person I am trying to reach is 20.1.1.3. In this situation, the data Y will be passed through each of our routers. Yes, first, it is sent to our RTB, and once RPB receives it, it will take a look. Do I know where 20.1.1.0 is? Now that he has received it, he knows, because 20.1.1.0 is a subnet of his own. Specifically, his S1 0.00 subnet. So in this process, he can help us forward it. And in the future, he also knows that this address is one of his own interface addresses. So originally you came to find me, and in this process, he needs to reply to you. First of all, everyone needs to consider one thing here. Does our RTA1 initially know where 20.1.1.0 is? He doesn't know. If during this process he is unaware, we need to manually assign him a static route, telling him that if he wants to find 20.1.1.0, he should go to RTB, specifically to 10.0. 2. So here, we need to write such a static route. And because it is our broadcast network, during this process, we need to assign it a next hop. In the future, does RTB need to have this static route written on it? It won't be necessary, because this is its directly connected route. And as for RTC, it also doesn't need to write it or be told where 20.1.1.1.0 is, because this is its own route. The IP address is on itself. In the future, it also needs to send return packets to our RTA. Return to where on return to this point 10.0.0.0. However, since our RTC is not directly connected to RTA, it doesn't recognize your IT. In this situation, we need to write a static route for it, telling it that if in the future you want to go to 10.0.0.0, then send it to our RTB and send it out from my own S100 interface. Because in this process, the S is using the PPP protocol, a point-to-point link, I need to specify the interface here. Once RTB receives it, during this process, the left interface is the 10.0.0.0 network segment, so it knows where it is and can directly help with forwarding. Then RTA can receive it. So when configuring static routes here, you need to consider that our static route communication is bidirectional. Therefore, there must be a route to go and a route to return. This is our static route. Additionally, within our static routes, there is actually a special route called the default route. What is a default route? It means that if in my routing table here, no, there isn't any that goes to this destination. But if my routing table has a 0.0.0, then here it represents the default route, meaning anything I don't recognize, I will go to find it. Now, in this process, RTA needs to forward the data packet, and it forwards this packet to a subnet that is not directly connected to it. And who does it forward this packet to? It forwards it to 10.0.0.2, because to go anywhere, it actually can only be routed through this RTB. In the future, whether it's looking for 10.0.1.3 or up to 10.0.254.00, it actually all goes through this RTB. So here, as long as it's not in my routing table, I'll just hand it over to you to help me forward it. In this case, I can't determine who the destination I'm looking for in the future will be. So, I write 0.0.0.0 here. It represents uncertainty. And similarly, I'm also unsure about the address or subnet I will need to find in the future, or what its mask is. So we use 0 as a placeholder. As for the next hop, I hand everything over to 10.0.0.2 to help me forward it. This is our default route, meaning if I really can't find it in my routing table, it's okay. I'll forward it based on this default route in the routing table. I hand over everything I don't recognize to you. We configure this default route at the exit of our enterprise network in DOT. As we access any external network, we have to go through the service provider. Now, we set it up on the interface that connects us to the service provider. On the device that connects to this, we will configure a default route which allows our device to forward and send to any address on the internet. Here we configure this 0.0.0.0, which surprises us to the network that interfaces with the service provider, meaning something like 1.2.3, 254. In this way, we can normally send the data packets to the other party, Often, we configure it this way on the outbound device. And this is our static route. If you want to learn Huawei certification technology, or want to obtain the Huawei certification question bank, please send a private message. I can also leave more comments below the video for technical exchanges.